I'm trying to learn particle physics. What? First, I'm trying to learn particle physics, and today the standard model. And with this part 2, we already read the introduction, and with while doing grip strength training. And if you participated in a grip strength training in the second part of the video, that is at your honest. All these entities are quantum particles. We're talking about the electrons, the quarks, and the neutrons, and they are all inside of the fermions. And there are also leptons. And there are bosons, and they are like photons. Okay, photons, they have something to do with light, so far I know. Light is going from one side to the other. And these are photons doing, and these bosons are doing similar things. Now, and all these entities, these quarks and leptons and neutrinos and electrons, they are quantum particles. Okay, they are particles, and there are different types of particles. There are particles which are wet, and now they are quantum particles. And these wave particles don't move according to the tidy rules of classical Newtonian mechanics, but dance to probabilities bounded by bizarre rules in an abstract mathematical space, and the workings are governed by quantum field theories. Okay, they don't move away as Newton describes it. They seem to move wave-like. They are dancing in a probability by, quote, bizarre rules. And how they work is then try to explain quantum field theories, because we're moving inside of a field where all these quantums are, these quantum particles, and now we're having theories to describe how the quantums are moving in that area. That is better in quantum field theories. Meaning, okay, the Newtonian mechanics, they mean something like if one force pushes in the other direction, the other one goes into the other direction. So these strict rules. One force in the one direction has opposing force into the other direction, is one of the three rules. What was the other one? There's two other ones. Some very strict rules, saying if you push with 100 kilograms into that direction, you are pushing into the other direction with 100 kilograms. If you're pushing a dumbbell with 100 kilograms upwards, you're pressing with your feet 100 kilograms more into the ground. I don't know if it's true, but whatever. Very strict Newtonian rules. These Newtonian rules saying very exactly that thing moves there, and that is why that thing moves there. Yes, my other thing was about acceleration and how it changes. So if you're driving in a car and you hit the brakes, you will move onwards and you will come into the seatbelt if you will. So these very strict rules, how everything moves, we can specifically say a car driving into that corner with that speed will stay on the street if it has lower than 60 miles. If it goes faster, it will topple over. We can say that specifically, we can calculate it. We can calculate the roller coaster, and we can say in that curve, the roller coaster will have that Newtonic force of 4 tons with the whole thing to the side. So we have to have screws which hold more than 4 tons. And we can calculate it very exactly. And it's every time the roller coaster goes into that curve, every time exactly the same. When you go onto the scale, it's every day the same. But when Newtonic force, I don't know if gravity is non-Newtonic force. Whatever, it's every day the same. All these forces are every day the same. It's every day the same what you have on the scale, and it's just depending on what you have eaten or how your metabolic system works, what the scale shows. But not tomorrow, they all have changed. The gravity will not have changed. Okay, everything in our whole work, I explain this a lot because I want you to really understand it. In our whole world has very fixed rules. This book has always the same weight. But now with quantum particles, all inside of these fermions, they don't do that. They don't work by the Newtonian mechanics. They are dancing in probabilities, in wave-like movements. I think they're pretty good at understanding what I explained. Hopefully, but what I explained is what is here explained. But we're going on. As we have seen, the mathematical structure of quantum fields gives them an odd property. Let's do it again. As we have seen, the mathematical structure of quantum fields gives them an odd property. Okay, property, before we only get the answer. means it has that size, that weight, whatever no weight is. But now we can't really say in this quantum field, so an area where these quantums are. And quantum particles are specific things. And we can't say that thing has a size of 1 meter because they are all moving totally unstructured from one side to the other. And we're trying to explain them with quantum field theories. And we're going to say, now the thing is not completely whatever doing what it not does, it's going from one side to the other. That is so far as I understand it. They can create particles from empty space and destroy them again almost at will. Let's do it again. As we have seen, the mathematical structure of quantum fields gives them an odd property. So also what we can do. And with quantum fields, they cannot just do normal business, like existing. They can create new particles from empty spaces and then destroy them again, as if it would be at will. We understand it illustratively, completely literal. There's nothing, and from nothing there's created particles and then they're destroyed again, and it all happens at will of a quantum field. Now we're going to read it. Thus, according to the theory of quantum electrodynamics, two electrons repel each other thanks to a photon, the boson that transmits the electromagnetic field that appears from nowhere and passes from one electron to another. Now I read that whole sentence through because already 1/3 in, I was out, so why not just read it to the end? It was anyway, I had to repeat it. So, thus, according to the theory of quantum electrodynamics. Okay, there's someone saying electrons are moving that way. And if I say electrons, so small whatever, they are moving from left to right, that is dynamic, from moving from left to right. And I say that electron will move from left to right, that is electrodynamic. And if it's about quantum electrons, then it is quantum electrodynamics. And we are someone saying these electrons inside these quantum fields, so these electrons inside of these fermions, inside of these areas, and we are calling them all quantum particles, they are moving from left to right, basically. Now what it's actually said is that two electrons repel each other thanks to a photon. They're two electrons, but they don't like each other, they're going apart. And that is because of a photon. And that photon is the boson, so photons are bosons. There are also a handful of bosons like the photons. Okay, photons are bosons, and inside of them there are photons. Thanks to a photon, the boson that transmits the electromagnetic field that appears from nowhere and passes from one electron to another. Okay, there's a photon, and that photon is separating the two electrons. That photon is transmitting the electromagnetic field, which comes from nothing, from nowhere, and goes on to the next electron and splits them also up. And then goes to the next two electrons and splits them up. Until all 6 electrons are split up, but maybe there's just one photon and it's busy with the third one, and the other two are again pairing up again at the same time. No, they haven't said anything contrary so far. Okay, I think that is enough. Wherever we are, we're still able to make illustrative picture-like illustrations of it. Now it happens in a physical world, so why should it not be possible to make a physical explanation of it? Yes, a physical, like an object explanation of it. Now, if you're here for the next part, where we're trying to read on what is written about the standard model, you can go directly to the next part. I don't know how it started in the sense. If you're here for a standard model, you can go directly to the next video. We will do now just the grip strength training. If you participate in the grip strength training, that is at your own risk. I forgot how we started. I think we started with that, just with spotlight. Down with the fist, and if you participate in the grip strength training, that is at your own risk. Again, down. And down. And one last time down. There you go. And now the flashlight. Fists to the inside. And to the outside. We have 3 rules. The first rule is that we're stopping immediately as soon as there's pain. The second rule is that we are going only as fast as we can go with a little bit of effort. And the third rule is that we're not overdoing it. just not strength, not to completely exhaust. Next exercise, fists, and we're going up to the side, so we're making a circle, down to the outside, up, and the other way around to the outside, down, over. Next exercise, the T-Rex in the morning, flat hands out and down, putting it up. And last time up. And next exercise, the T-Rex in the gym. Take a tennis ball. If you don't have one, just make a strong fist. Press into it. And release again. And press again. And release. And press again. Or to the other hand and press again. Release. And press again. Release. And press the last. And next exercise, the frog testing the water temperature. Arms next to us, flat hands. Bring them down with flat fingers. And up and make strong fists. Down with flat fingers. And up with strong fists. Last time down, flat fingers. And up with strong fists. And the next exercise. Arms in, strong fists into flexion. Now out into extension of the hands and make 5 fingers again. To the inside, strong fists flexion. To the outside, extension 5 fingers. Inside, strong fists flexion. So last time to the outside, extension 5 fingers. And up in strong fists flexion. And the last exercise, we unfolding rocket boosters. Long arms, strong fists, and bring these fists to the inside again. To the outside, extension 5 fingers. Inside, strong fists into flexion. Outside, extension 5 fingers. Inside, strong fists flexion. And the last time, outside extension 5 fingers. And we're ending. Okay. Now we're going with moderate pressure over the middle part of the lower arm to relax the extensor digit toe muscle which lies there. And on the other side. And that was a grip strength training. I thank you very much and until the next time.